Hey guys, welcome to YRR Help, and today we're going to discuss about Java 8 Lambda expressions. So we're going to tell you what is a Lambda expression, and we're going to discuss about what is the purpose of Lambda expressions in Java. So basically, before actually talking about Lambda expressions, let me give you a quick introduction on what is a functional programming. Right now, let's take an example of array list here. Here I have an array list and I'm calling an add method with a parameter as a string. Right, so what I'm doing is I'm actually passing a data as a parameter. Alright, now it can be any data, it can be even an object, Java object. Now let's take another example here. Alright, instead of calling add, I'm calling sort method. Now imagine what is the we all know about a sort method in Java, right? So what we are actually passing is we are passing a logic. Well, this is not just a plain data, or it's not just a plain object, but what we are actually passing is we are passing a logic on how to sort, right? So this is not a data, but this is something like a function or a logic, a set of instructions. Alright, so this is something different than what we saw in add. Now let's take another example of thread. Right, now while creating a thread, we have to specify what to run in that thread, like what does the thread actually do. So we have to pass something like what are the set of instructions the thread is going to run. So we have to specify a function or a set of logics, a set of instructions that a thread is going to run in behind. So this is also quite different from the first one, which is passing data as a parameter. So these two are quite different. So these are not just passing data as a parameter, but instead what we are doing is we are passing a function or a logic as a parameter. Right, now generally for thread we will call a runnable interface, and for sort we will call, I guess it's comparator or comparable comparator. Right, so that's what happening. So obviously we all know that Java cannot support functional programming. So what do I mean is that you cannot just simply do something like that, like if a greater than b, do something. So you cannot pass that as a parameter. So what Java internally does is that it allow so it will ask us to implement an interface. Like for example, if we see at thread implementation, right? So it will ask us to implement an interface, and it will ask us to override run method. So what we are going to do is we're going to override our business logic inside this run method, and we're going to pass that runnable interface or runnable instance as a parameter. So what we're doing is we are passing an object as a parameter, and we are embedding that logic, whatever the function, inside this run method, and we are passing runnable. So that's how Java internally does the functional implementation. The same thing goes for sort method also. Sort also, what it does is it will forcefully ask us to implement an comparator interface, and it will ask us to override compare. So what we are doing is, as I said, we are passing an business logic inside this compare method, and we are passing that object to sort. So internally the thread class or the sort method, it will call that runnable implementation, and it will call that particular method, so and so method. Like for example, so for runnable we have run, right? So it will call dot run method somewhere in the code, right? So it's calling that run. So whatever we are passing here as a business logic, it will grab it here and it will run. So that's how internally it works. So you don't need to worry about all those things. Now let's try to implement that. Well, this is nothing new here. This is just old. It's not related to Java 8 or something. Right now we have to implement that runnable interface. So let's just a simple print statement. So this is how we generally use it to do, right? So what we're doing is we're just passing our business logic to a thread, right? So to a runnable thread. So that's what we are doing. So everything looks fine, but the problem is, if you look at the code, we have so much boilerplate code. I mean, this extra interface just for one single line of code, we have to implement 10 class and we have to override method. This is just an extra overhead, and after a long run, if you look at your code, it's just gonna like some unrelated classes will be inside your class. So that's what happening. So now if you think logically, so this thread is always extending one interface. So what we can do is the compiler always know which interface you're going to implement. So we can even skip this one, because as I said before, the thread is always accepting a runnable target, not extra interface, not another interface. So the compiler automatically knows which interface you're going to implement. And the thing is that somehow, if you are able to manage that, if you have only one abstract method, just the one abstract method, then the compiler can easily identify which method you're going to override. So like this way, you can even skip this one and this class also. So that is exactly what Lambda expression does. So a Lambda expression helps you to remove this extra boilerplate code. So by the extra boilerplate code, I mean this creating a new instance and overriding this method. Now, as I said before, we can remove this entire thing, and we can just do something like this. So this is a syntax. The first one, you have to pass the parameters. Obviously for runnable, we don't have any parameters here. So run method does not have any parameters. So I can just keep it blank here and then right arrow mark and after that your sole business logic. So whatever the logic or whatever the instructions you want to write. So that's how Lambda expressions work. Now if you look at my code, it's quite simple. Now I have just my business logic here, nothing else, no extra boilerplate code. So this is how the Lambda expression works. Now let's just say if you have an input parameters for something like, let's say, sort. So if you look at my sort method and comparator class, if your syntax is something like, it accepts two parameters, which is obviously object1 and object2, and you have to return integer -1 0 or something like that. Now let's do that also. Right, as I said, the first thing is you have to enclose your parameters and your business logic. So this is the syntax, and so here I have two parameters. One is object1 and object2. And remember guys, you don't even have to specify data type like this. I mean, it's not even necessary, because the compiler can easily identify the object parameter types. All right, now other thing is you have to return something, right? So obviously in your method you have to return something. So for now time being, I'm just returning -1. So this is how you implement a Lambda expression. So these are my parameters, where I have two parameters and I'm returning a statement. Now the thing is that if you have only one single line of code, you can even remove this curly braces. You don't even have to specify this braces. So that's just very simple as that. Sorry, wait. Sorry, my bad. Alright, you can even remove this statement. The compiler gonna automatically recognize that compiler gonna automatically recognize it as a return statement. So but in case if you have multiple lines like 2 or 3 or 4 lines, then you guys have to make sure that you have to return. So this is all about lambda expressions. Now let's talk about functional interface. So what is a functional interface? So what is a specific need for that functional interface? Now if you remember correctly, I said that lambda compiler can easily identify which method you are going to override. So now let's just say if I have another abstract method here, all right, now at the time compiler doesn't know which method you are overriding, and compiler will obviously make conflict state. Now for that purpose, you always have to make sure that your interface must and should have only one method. So that kind of method is called a functional interface. All right, it's not necessary that you have to use this annotation, but there are two reasons why you have to use this annotation. The first reason is that it will make your interface readable. So let's after a long time, if you come and look at your interface, you can easily identify it as a functional interface. Now another thing is that let's say after some time, if a new developer comes and if it tries to add a new abstract method, the compiler will automatically throw an error because you have specified it as functional interface and you cannot add any abstract method. So that is the reason, that is the sole purpose of functional interface, guys. It will allow you to use lambda expressions. And one more thing is that it's not necessary that it must and should have only one method. It can have default and static methods. So let's say for example I have a comparator which is also a functional interface, right? If you see here, this is also a functional interface, but it can have default methods and also static methods, right? You always make sure that it has only one abstract method, not more than that. So this is about lambda expressions and functional interface. So functional interface and lambda expressions are linked together. So lambda expression behind the scenes, it's implementing an functional interface, and it's doing the same thing with what was doing before, but in a different way. So thanks for viewing, guys. If you like my video, don't forget to subscribe us.